Okay, our next thing we need to look at is graphing inequalities when there's only one variable. So this is slightly different. If you look at what we have here, we've got 5 is greater than x squared plus x minus 2. Well, before I even start, I'm going to put it in standard form. I'm going to get a 0 over here. So I'm going to subtract 5 from both sides, and I'm going to have 0 is greater than x squared plus x minus 7. Now if we think about what is this asking? Well, think of your equation side as the graph. So it wants to know, when is the graph smaller than 0? Well, if you think of what a parabola looks like, it wants to know, when is our graph smaller than 0? Well, down here for this sketch, it would be smaller than 0. So it's asking us what x values will give us the graph down here. So what we need to do is we need to go ahead and graph this. So practice graphing this one and see if you come up with the same graph I do. So pause the video now. Okay, now when we go to graph this, we have to pretend like there's a y here so that we can use the same strategies. So our vertex, we would do the opposite of b over 2a and end up getting -1/2 for the x-coordinate. Plug that back in for our y-coordinate and we get -7 1/4. Then do your table of values and plot your points. Now I've plotted the points over here on my graph. I've drawn my dotted line in there. But now notice it wants to know, when is the graph smaller than 0? Well, 0 is right up here on our x-axis. So we have to find these critical points there because those are our cutoff points. What we're going to need to do is either try to factor it, complete the square, or use the quadratic formula to figure out what are the zeros of this graph. So I've decided that I'm going to go ahead and use the quadratic formula to figure out what are my zeros. So see if you can take our equation we have right up here and find the zeros using the quadratic formula. So go ahead and pause it. From the quadratic formula, you should have ended up with -1 plus or minus the square root of 29 all divided by 2. So our two zeros, these two critical points on our graph that we're trying to find, are -1 plus the square root of 29 over 2 and -1 minus the square root of 29 over 2. Now we need to put them in their appropriate spots. So you've got to think about which one would be farther to the right and which one would be farther to the left. Well, the -1 plus the square root of 29 would be the one farther to the right. So I'm going to go ahead and write that up here. And then the one farther to the left would be the -1 minus the square root of 29 over 2. So now we have to look back at the question. It wants to know, when is the graph less than 0? So less than 0, we're looking for the values between our two critical points there. So we want x in the middle of our left point, so -1 minus the square root of 29 over 2, and of our right point, -1 plus the square root of 29 over 2. Now we just have to decide, does it need the equal portion of the inequality or not? And you get that from your original inequality. So since it did not have the equal sign, this would be our expression. Now this would be considered an AND expression because x is in between these two things. And that's only because our formula, or our inequality, was asking us for the values in between these x's, because that's where our equation was less than 0. If it had been asking us when the graph is greater than 0, we would have had an OR expression because it would have been looking at these two tails instead of the part in between them. And then our inequality would have just been written differently. It would have been an OR statement instead of an AND statement. We still would have had the same critical values, but instead of an AND, we would have had an OR. Okay, now solving the inequalities graphically can be time consuming. So we're going to look at how do we solve them algebraically. Well, if you think back to what we had to find those critical values. We had to find the zeros. So when we solve these algebraically, we're going to find the zeros first. You can find the zeros any way you want. If you want to try to factor it, you can factor it. If you want to complete the square, you can use the quadratic formula. Any of those will work. So you pick whatever method you want, use that method to find the zeros for this inequality, and then check back here. So pause the video now. I chose to factor this, and when I went through and factored it, I got my zeros to be x equals -6 or x equals 3. So now I need to think about how I'm going to use these two critical values to write my expression. The first thing I'm going to do is I'm going to just sketch a graph of what this one would look like. It doesn't have to be accurate. I'm just going to do a sketch of it. Well, I know my intercepts are at -6 and 3. And I know my graph opens upward because there's a positive number here. So it's going to look something like this. Now I want to go back to my equation here, or my inequality here. And I want to know, when is the graph greater than 0? Well, greater than 0 is when I'm above the x-axis. So I'm looking for these two tails. Now notice the tails go away from each other. It's not the values in between. We're going to be looking for the x values that go away from each other. So that tells me it's going to be an OR. Now I'm going to put these numbers on a number line just so I have a visual. Here's my -6 and here's my 3. I know that I want the x values going away from each other. So I'm going to be looking at these values and the lower values. Now all I have to decide is how I'm going to write that expression. Well, for this lower half, I want x to be smaller than -6 because I want it to be to the left of -6. For the upper half, I want x to be greater than the 3 because I want the x values that are to the right of 3. So my answer for this one would be x is less than -6 or x is greater than 3. So if we look back at what I did, the first thing was find the zeros. Second thing was sketch a picture so I knew which part I was looking for. And then I used a number line to help me write my inequality. Okay, so now it's your turn. Complete these two problems and bring them to class.